Good morning, everyone. I think it's safe to say creativity is having a moment right now. I've been in the space of creativity and education for quite a while, and 5 years ago, if we had created a top 10 list of what are the most burning, urgent issues in education, besides niche circles, I don't think creativity would have been on that list. But boy, has that changed. The questions, what is creativity? How do we teach it? And why does it matter in every subject and discipline are echoing through the halls of schools and campuses louder than ever before. And I think our little friend generative AI is a large reason that is happening. But even outside of formal education, at a broader cultural level, as soon as ChatGPT came on the market, fall 2023, we all heard this sentence starter. But AI will never be able to do. And one of the key words that was rushed to finish that sentence was be creative, do creativity. So it's an exciting time, it's an important time, and I'm really excited to introduce 4 educators and researchers who, from different disciplines and different areas, are going to help us grapple with this big question. So I will introduce them one at a time. They have a hard task. They have 5 minutes to give you an overview of everything they're doing in this space. We'll bring them up one at a time, and then we'll all, in front of you, have a discussion, maybe even a debate afterwards. So without further ado, from the Center for Computer Research in Music and Acoustics, please join me in welcoming Chris Chafe.
Okay, well, thank you for taking a few minutes to listen to my ever-changing life in presto tempo right now. It's an amazing moment. And I come at this from computer music and having worked as an artist, but also a teacher for quite a long time. Most of where we end up now is sort of sophisticated musicians using computers is often with shrink-wrap software. So it's software that's been developed for a very special purpose. Maybe we teach that, but often at a lot of institutions, especially Stanford, we teach how to make that stuff. And I have a statistic that I just kind of mulled over recently, which is back when I started, the industry spec was 5 lines of code per day per programmer, debugged, tested, documented. And then, this is a 50-year span. Halfway through it, I'm up to about 50 lines of code. Last summer, 500. It just went, exponential like that. And 5 or 10 lines, 500 or 1,000 lines, doesn't matter, it's exponential. So we're in this place, and I'd like to show you how that translates in what we can do as an ensemble in music. So go ahead, hit the clip that I'm providing you. So this is Network Music Performance Co-Design Ensemble, and this is a performance from 10 days ago in the Bing Auditorium with 8 students. And they're playing instruments, and you can bring the volume up a bit. They're playing instruments and laptop instruments. So in this case, everyone's sharing an instrument that we passed around in the ensemble in rehearsal, and it's part of a texture that we're working up. It's a longer piece. I asked a class in September to do this, just to find out if this works at all. That's from a prompt. 31 students did the same prompt, and here is the result. It's actually 31 usable web apps that run in browsers. This is the class. They're making hydrophones and learning how to solder. And the next thing I was going to do in the class after this was sort of, introducing perceptual phenomena. So the Gestalt principle of common fate. And this is around Halloween, so forgive me for this is a more complex program that I did. And all of the dots are individually programmed in the web app. And common fate is when the dots move together and you can pull out an identity. So that was quiet. Let's do it with the THX logo theme, which you may remember from theaters. So scary stuff, Halloween compatible, and then try something even scarier. Sort of like a facial theremin. Theremin is the sort of air instrument from years and years ago. So these are all, like kind of developing technical things that are really tough to program. Would take that 50 lines of code and it would take 10 days and so on. But what about doing new realms, like imaginary things? Ask me later what spider ballooning is, but we put this one prompt and developed a quartet that we're about to rehearse tomorrow. Spider ballooning is the scariest thing that happened to me in September, but I'll leave it there. And this totally captures it in a one-line prompt that we could modify and do something else. Anyway, thanks for listening, and on to the next speaker. So, yeah.
All right, our next panelist is actually near and dear to my heart because I did my PhD here about 15 years ago in modern thought and literature, which is sort of, choose your own adventure. But I was, a humanities and education guy. And then I took an intro to computer science course with Marin, opened my mind to computational thinking, and honestly changed my career trajectory because now here I am in tech. So please join me in welcoming from the Department of Engineering, Marin Sami.
Thanks very much. And you're really too kind. The check's in the mail. What I want to do is spend a little bit of time today talking to you about 3 provocations on creativity and generative AI. For about the last 8 or 9 years, I've been co-teaching with a philosopher, and so I've moved from the world of thinking about problem and solution to provocation. So first provocation, or before we get there, what do we even talk about when we think about creativity? This is the kind of the computer scientist coming out, right? We need to define it. I like to think of it as novel approaches for problem solving, being able to come to some new problem, bringing fresh ideas to that problem to be able to generate a solution. There's lots of different definitions we could think of. This is just kind of our working one for the next 5 minutes. So here's provocation number 1, thinking about education as a product versus process. And this is something I probably don't need to tell most of the people in this room, but I'm going to tell you anyway because it's in the slides. What do we think of? When we think of education, education obviously is about learning. That's the goal. And learning is a process, right? There's a whole bunch of things like research and writing and problem solving, all these things that students do as part of the learning process. But what we do is we evaluate products. We ask students to turn in papers or a program or solutions to a problem set or whatever the case may be. And for many years, basically our conceit in education is that a strong product that we assess is indicative of a strong process that the students went through to generate that product. And what generative AI has basically done is taken that assumption that we've had, for a couple hundred years in education and just fundamentally broken it and said basically you can generate a strong product without engaging in a strong learning process. So what does this mean for us? Right, what it means for us is that we need to think about ways in which learning engages more with the actual process rather than just asking students to produce a product and expect that the product actually meant that a good process happened. Part of that is also realizing that even experts in technology can be lulled into a false sense of security by these processes or these algorithms that exist to basically short-circuit processes. I'll give you one example that comes from my domain. Dan Benet and some of his students, he's a computer network security researcher in the computer science department, did this experiment a few years ago. Took a group of people, gave them generative AI tools and said, build some stuff that has to do with computer security, like a login, authenticator, stuff like that. Another group of people, these are trained programmers, right, had to do the same thing but without generative AI tools. And then they checked how secure was the code and how strongly did they believe their code was secure. And here's the interesting thing. The folks that had access to generative AI believed that their code was more insecure, and when it was actually tested and reviewed, it was less secure, right? So it gives a false sense of what we are actually producing with these technologies. And relative to the last panel, if we think about one of the critical factors is to have people be critical of AI. Right, to think about how their learning process is actually impacted by the use of these tools. So that gets me to the second provocation, topics versus tools. Generally, when we think about generative AI in a curriculum, it requires a curricular organization. And you're like, Maron, that's tautological, right? You just told us it's part of a curriculum, so of course it needs a curricular organization. Yeah, seems obvious, doesn't it? Except we don't treat it that way. What we do is we think about a curriculum being organized by topics that a student should know, but we don't think of generative AI as a topic, we treat generative AI as a tool. And when we think about tools, the decisions around tools are often made by individual instructors in individual classes, and there isn't a building of a topic in the same way we might think about the ways you go through, for example, learning math, building on previous classes. And so I think of that as our challenge is to generative AI, not to consider it as a tool, but consider it as a topic and build a curriculum in which we teach how to use generative AI to foster things like creativity and deeper educational outcomes by actually treating it as a topic where, for example, here's just a stylized illustrative example so you get a sense of what I'm talking about. To give an introduction, we can tell students about what these tools are, where they come from, maybe what a generative AI model is. In a subsequent grade or class, we might tell them about how do these things actually hallucinate bad results, how they might incorporate bias into what they generate, and thinking about the notion of verifying references that these things produce, which now gets into a different learning process that they need to do to effectively use these tools. And ultimately, we might teach them how to be really effective users of the tools. For example, research that's been done on telling models, for example, to think step by step, which causes them to solve problems that they don't solve when they're not asked to think that way. These are things that new research are revealing about how to use the tools effectively, and there are things that should be taught to students because if we don't teach them, they will teach themselves, and what they've already taught themselves to do for 70 or 80% of them is use these tools ineffectively to short-circuit their learning process. So can we get to the final provocation, which is around creativity and thinking about novelty versus regurgitation? Can AI actually produce something novel? Now, here's the interesting thing. A lot of critics say AI is just trained on certain information, and it can only regurgitate that information. Okay? What do we do for most of education? Right? Exactly the same thing. And somehow we expect students to be able to generate novel results. So the provocation there is, can we actually help AI to produce novel results in concert with human beings? I think the answer there is yes. But if we want to be able to do that, what it means is we need to teach creativity to both human beings and AI to be able to work in concert. Rather than just expecting students to generate yet another essay about the Civil War, we don't need more essays about the Civil War. What we need them is to think critically about engaging with the tools to do it. And so I'll leave you with the final points in terms of AI to spur creativity. Can AI generate new ideas? It's already been used by, for example, hard sciences to generate hypotheses that the scientists themselves had not actually considered before. And people in mathematics, for example, see the future of mathematics as working collaboratively between humans and AI to be able to generate larger results in math. So thanks very much for your attention.
All right, our next panelist is here in the Graduate School of Education, but I just learned was long ago an intern at Adobe, so no wonder creativity planted a seed. Please join me in welcoming Hari Subramaniam.
Okay, thanks, Brian. Hello, everyone. very recently was asked this really interesting question. If AI could fix one thing about today's education system, what would it be? Now, before I give you my answer, why don't you take a second to think about how you might answer it, although Mehran may already have given you some clues about it. Well, my answer is to equip students with the infrastructure to learn by creating things. You see, the ultimate effect that education has on a learner is to advance their capacity to create, to generate ideas, to solve problems, and to build things that didn't exist before. Across all these different domains, whether it's design or engineering or science or media or craftsmanship, creation is the ultimate test of understanding. Yet, in today's classrooms, a lot of learning is organized around what to know instead of what to create. Students learn facts and concepts, they memorize procedures, and they solve familiar problems. And we find that this is a little bit problematic in many ways because, one, it introduces this purpose gap. When knowledge isn't acquired purposefully, when learners don't have the opportunity to create while learning, we find that the knowledge they acquire is often abstract and fragmented. You may have a student who aces like a physics test in fractions, but will not be able to explain why a sled slides differently on ice compared to concrete. And my argument is that sort of creation fundamentally changes how we learn. When we create, we are forced to sort of organize knowledge and represent knowledge in purposeful ways. We are forced to make connection between ideas, and we are forced to consolidate knowledge in a way passive consumption cannot do. So here is an example where imagine introducing like 3D geometric shapes to a student. And if you just do that, all they're going to remember are these different shapes. But instead, if you ask them to model a real world object, in this case a sneaker, the student now needs to understand how these different shapes combine, how do edges align, how to compute complex volumes, and so on. All of this is what makes knowledge that we acquire in K-12 education more purposeful. So if creativity and creation is essential for learning, how do we make it accessible to all learners? And this is where like AI can play a role. First of all, AI can sort of provide the infrastructure to lower the floor for creation to get students get started in creating things. What you're seeing here is an example where a child sketches an ordinary everyday scenario, a car on the street. AI recognizes the scenario and generates what we call situated physics brushes, in this case, like a physics brush for friction that the student can then paint over their scenario. Notice that we're not introducing friction as this abstract formula. Instead, friction is presented as a creative tool where the student can paint the street with ice and paint the street with gravel and see how the car moves on these different surfaces. They can explore and start asking questions like, will the car move faster on ice? What happens if we combine like ice and gravel? Or how much friction or what material is needed to get the car to completely come to a stop? The concept of friction sort of like emerges through this process of exploration, through this process of testing out their intuitive theories about physics based on everyday behavior they've already observed. And over here, AI can actually help by sort of by analyzing these scenes and producing the necessary creative tools for learners to create, but also automating away the more like a difficult or mechanical process of creation, in this case, like simulating an animation. A second example is, in addition to lowering the floor for creation to get learners started, it can also raise the ceiling where learners can be more expressive and can expand based on their understanding. What you're seeing here is a creative tool for generative art. Over here, the learner is using AI and natural language to combine concepts in new and bespoke ways. They are trying to map the jellyfish behavior, how a jellyfish moves, with abstract, rigid, fractal shapes. If we were doing this in a traditional programming paradigm, then the student would have to learn how to program these individual behaviors, how to sort of engage in like construct recursive patterns, and how to apply these interactions. But instead, over here, the learner can focus on creative composition and thinking about conceptual blending and thinking about abstractions, while AI can do this harder technical work that is not central to their learning. And finally, AI can provide feedback and guidance in bridging this gap, or like this, going back and forth between knowledge and practice. On the left, what you see is a simulator where a learner can adjust the angle, force, and gravity to understand the trajectory of a basketball, and thereby understand how the laws of motion works. And AI over here can help the learner in thinking about like how to run these experiments, in understanding or interpreting the evidence or the observation that they generate through each runs. On the right, you're seeing a tool where blind and low vision learners can create accessible content and engage in spatial reasoning. Over here, AI can provide rich descriptions in helping them construct this understanding. So in conclusion, I want to sort of leave with this provocation. I find it a little bit ironic that we're using a technology that is somewhat powerful today in helping learners consume knowledge while leaving the act of creation to the AI. And I think we should sort of think a little bit differently and focus on how do we equip learners to be more creative and use creative work in engaging in sort of like their own cognitive task of learning. So in summary, knowledge is powerful. Creation helps learners sort of organize and structure knowledge in more meaningful, usable ways, and AI should support this. Thank you.
All right, and our final panelist, also from the Graduate School of Education here, is actually doing incredible research looking at what happens in real classrooms when we take a specific tool and a specific creative task. What happens with that learning? So please join me in welcoming Guy Lischent.
Thank you. Thank you very much. Being an economist by training, over the years I've often been confronted with these ideas that, this boom is not going to be followed by a bust because this time is different. Or, this depression, we're never going to recover from this because this time is different. So let me present you with my version of this time is different. Why I think Gen AI is not just like a calculator. I have to learn how to move it forward first. Oh, the green one. Oh, thank you. We've heard other metaphors for Gen AI. And I think there's at least two big differences between the two technologies, and I think they are important for what we're discussing today, the relationship to creativity. So calculators, they're available even in super low resource settings, such as the ones that I often engage for my research. Whereas Gen AI, we know it depends on devices, internet, subscription services. What is free today might not be free tomorrow, so we might worry about that, especially when it comes to equity. But there's one extra dimension that I think might be pretty fundamental, at least at the moment, which is the extent to which these technologies automate tasks. So calculators never do the whole thing for you, unless you're using a very sophisticated scientific calculator. They will do the repeatable kind of algorithmic components of the task and still leave it to the student, to the user, to interpret what the problem is, to figure out what calculations have to be inputted into the machine such that you get the answer that you want. Whereas Gen AI, at least again at the moment, without guardrails, we'll talk more about that, in principle can automate all the components of a task. And that, I want to argue, can be pretty fundamental to how we might or might not encourage creativity and learning. So it's, once you can automate everything, it's pretty obvious that, we need guardrails if we want to use it in the classroom, especially in K-12. And then once we start thinking about guardrails, hard questions emerge. Like we want the technology to scaffold learning, to help students acquire knowledge. So what's the right model to do it? Until what point do we want the technology to do the task for the students? What kind of help are we willing to provide? And then, as a result of this guardrails, scaffolding, and supports, are students learning more or not? So we ran this study. This is in Rio, Southeast Brazil, with middle school students. And we wanted to know that whether with some guardrails, student creativity would be helped or harmed by Gen AI assistance. We thought, I want to say, that there was a need to conduct a study like this, because first, if you just compare students that are already using Gen AI versus those who are not, and you try to ask who is more creative, that's not necessarily what the technology is causing, right, in terms of its impacts on creativity, because who uses Gen AI or not might be very different. And as I said, at the student level, at the school level, at the district level. So you want some more rigorous evidence that you can trust, so we're going to run experiments. The second thing is, you've seen studies like the famous, now I think people call it the MIT brain rot study, where some university students had access to a tool. Some wrote a text with Gen AI, some did not, and then their brain engaged less in it. They remember it less if they had Gen AI assistance. Well, to some extent, a lot of those studies, they kind of give you the tool and they take it away. And then perhaps it's no surprise that you get much worse once you no longer have that tool. So it's a big question is the education is about transfer. What can you do, not only in the same task that you had the assistance, but when the tool is taken away in a new task, can you transfer knowledge? If you're better at first, do you continue to be better? Or maybe you get worse. So that's what we're going to look at. We measure creativity because we're interested in this, in creating novel and useful ideas by focusing on divergent thinking, which is the ability to come up with new ideas. And we use two common tests in the literature. One is the alternative uses task. So we're going to give you an object and ask, what else could you use it for, other than the most straightforward use? The more valid uses you come up with, the better, the higher your score. Then the other test, so these are some of the objects they will do it for. And another task is the divergent association task. So I give you a seed word, and I say, come up with a list of 10 words that are as different from each other as you can, and you start with the first word. So, this is not an easy task. Here's just some guidance on how to do it. And here's our creative buddy. So we created some AI assistants, but we put guardrails in it. Here's the prompt. I just want to call your attention to the guardrail. So it says, if the user asks you for 10 words, just give it 3. So give some assistance, but don't do the task entirely for the student, okay? So I'm going to take you through the results very quickly because of my time. So first, this is just based on randomization. We're going to compare kids that had Gen AI assistance in the first test, the alternative uses test, versus not. Here they start the same. At the several trials, in the first one, you already see kids with assistance jump ahead, and then over the course of this test, when they have assistance, they do better. They're more creative. That's not surprising. Now, what happens when we take the assistance away? This advantage disappears. So at first, within the same test, doesn't seem like there is positive transfer. Already pretty bad news. But then the big question is in the new task, in the divergent association task, we're going to randomize again. What happens if you still have AI assistance, if you never had AI assistance, if you lost AI assistance? We're going to have 4 groups. So this is what we find. If you never had AI assistance, the control group, you do the best in this task. Now, if you continue to be assisted or you only had AI assistance in the second test, you do a little worse, but it's not statistically different. But now, if you had AI assistance at first and you lost it in the second test, then you do so much worse. Actually, the negative transfer is kind of 4-fold the advantage you had before. What's happening? I don't have much time to tell you. It's not just persistence. It's a little bit about don't have as much fun doing it, but most importantly, you start thinking that AI is more creative than you. And the negative effects are concentrated on those kids who really think that AI became more creative than them. So I think there's stuff for us to think about how access to these tools without maybe the right guardrails, the right scaffolding, might actually harm the academic self-concept. And that's pretty important, especially in the K-12 setting. Let me stop here.
All right, well, we swap a mic out. So we've laid a lot of groundwork here. This question's for all of you, and most of you covered in your quick talks. How do you define creativity? Because it's a broad tent: creative expression, creative problem solving, divergent thinking. How do you define creativity, and has that definition become more refined as generative AI has become part of your practice or your research? Chris,
wow.
You're the closest.
Sure, okay. In music, where what we're doing is communicating with the emotions and feelings of both ourselves, our inner selves, and our audiences, and trying to make a bridge. We're doing that through sound, and the examples that I showed were all, ultimately, the arbiter is your ear, and you need to be able to feed your ear, feed those emotions in the same way you do if you're practicing an instrument or you're composing with some of those shrink wrap tools that I mentioned. Where that falls short is if you don't have access to music all over the world, through your life, through history, the wide stage of music, and the fact that nothing is ever really truly de novo. It comes from other things. You're standing on shoulders of other pairs of ears, if you will. So that's how I define it. It's imagination, and it's also emplacement in something that is cultural, I guess. So I'll leave it there.
Great.
Yeah.
Yeah, there's so many. I just focused on problem solving because that's kind of the domain I come from. Is computer science. We think about writing programs often to solve problems, but obviously there's creative expression as a way of whether it be music or writing or sculpture, or, many other forms. But I think when we think from the standpoint of education, it's kind of tragic in some sense that we have one word for creativity because it means so many things. And I think keeping in mind the context of the creativity that we're trying to instill students with in a particular situation gives us more information about how we might do that with, say, for mathematics as opposed to art.
That's great. I think often when you ask a room full of teachers across subjects, do you teach creativity? There's not a lot of hands. But then when you define it, do you teach problem solving and different ways of approaching things? Suddenly the hands go up. So definitions can help or hinder.
Yeah. So I do. I make art in my free time. So for the longest time, I held this definition of creativity as sort of using imagination to produce something that's novel and surprising and interesting and like museum-worthy. But recently with AI, we've noticed that they've gotten really good at producing these artifacts of intelligence. And also in like working through my own research, my definition of creativity has shifted greatly from this artifact to creativity as this process of shaping ideas through this constellation of tools and knowledge and artifacts that get generated in the process. So it's more internal and cognitive than external and something that's created.
Yeah, I think there's at least two processes that interact to generate these novel and creative ideas. I talked about divergent thinking, which is kind of brainstorming phase. And then there's also convergent thinking, which is later how do I filter all these brainstorming outputs into something that really serves a task. And the task could be solving a real problem. It could also be being expressive and so on. Of course, how we measure those things is super hard. I showed you how two examples of tests that are used to measure the first one. They're very reductive, right? And it's just written expression, so there's no pictorial expression and so on. So when it comes to the challenge of measuring things, then we always have to reduce this complicated and beautiful abstract concept into something that's very, very constrained.
Yeah.
That's worth of the science.
That's great. Guy, while you're on the hot seat here, you introduced this notion of, good technology, if it's in the classroom, should ideally be lowering the floor or raising the ceiling. So maybe I'll start with you, and then we'll go back this way. What are ways in which you've seen that AI can lower the barrier of entry, especially for students who might struggle or not see themselves as creative or not really have the opportunities to practice creative thinking?
Yeah, I think so. In the context of this creative buddy that we developed, it could get assisted as simply as clicking a button, which is conducive to even kids that might struggle to write. A lot of these tests, what's challenging is they embed a lot of requirements, including the ability to read and write well. So sometimes they're more accessible just because there's different ways to which you can interact with that. But Harry showed a lot more examples of this. So I think lowering the floor, is easy to understand. Raising the ceiling, raising the ceiling is I think is not so obvious. You can see that, of course, if it's just divergent thinking, it can increase the set of things that you would list if you didn't have the tool. But it's not obvious, as we were talking about processes, not just outputs, that it's really mobilizing the internal, like self-regulating the process of developing the skills, such that the ceiling is raised even when you don't have access to the technology.
Yeah. Hari, how do you think about how this technology can lower the barrier of entry?
Yeah. Sort of building on the example I gave in my talk, right? I think the one thing that's really powerful about AI is like, one, it is dynamic. It can adapt to the learner's task either interactively or like, through some like system prompting. But also that it can take away a lot of the mechanical work of doing things. Like, in the past, like if a student wanted to see like how friction might work with their sketch, it would have required lots and lots of effort. But as I showed on like the video today, like you can take like a simple sketch, you can use AI to sort of understand the scene, and you can give them a friction brush that they can use. So that's sort of like lowering the floor. But now the student can start to expand on like, these counterfactuals, like what if friction didn't exist? And like what if there was an object falling on the street and there was no friction? Like how would this happen? How does friction interact with like acceleration and motion? Like can I sort of add a motion brush or like change the mass of the car to kind of like explore how friction and motion interact? So I think it sort of expands the space of possibilities in a more dynamic way, thereby getting people to like generate new knowledge in the process of learning beyond like what is already like presented to them or like what they need to learn conceptually.
Mm-hmm. Yeah, I mean, one thing I always hear, teaching introductory computer programming is, do we need to do that anymore? Is everyone just going to program in English? And the answer to that, I think, is many more people will program. They will program in English, and I don't want those people building the credit card transaction system on English. So I think it does lower the floor because now people have access to power tools. They can actually build things they could not build before by just describing in English to a computer system what they want to do and see the power of building something that gets executed for them. And I think that transformation from going from being a consumer of technology to producer of technology is actually hugely powerful for a student. Mm-hmm. So I do think that has already lowered the floor. And it has raised the ceiling because for people who are seasoned programmers who really know what they're doing, who are experts in the domain, it has made them more productive. So you go and talk to folks like Microsoft and Google, they say a large portion of our code base now is actually being written by AI. And the people who are very facile at using those tools are just much more productive than they were before.
Mm-hmm. Yeah, let me echo everything that was just said by going back to my examples. The 500 lines of code that I might emit in 1 hour today, what do I use that for? Well, like the pumpkin. That would have taken me way too long to generate that demo for teaching Common Fate. Well, there's a whole bunch of other Gestalt principles, and I can't wait to get there and make illustrations. So I think it's that one line that generates something usable. It elevates the conversation in a really good way that's going to affect what I can teach, how fast I can teach it. If you look at the Dayglow eyebrows example, that was just a lark. That was a DIY experiment by one of the students who accompanied a different assignment. Just try it out. Well, that opened up a treasure of different components that now are accessible, that were way beyond the scope of the class. So those kinds of things are just opening. And I think the accessibility, lower, we can do things right off the bat that are inspiring. And that's the I don't know, that's the readout from 2 quarters worth of doing this so far, hands-on.
Thank you.
Yep.
This topic could be its own conference that we could spend 3 days on, which I would love it as well. That's an idea. We should do this. But we're at time for now. The good news is we have a break, and so we can continue this discussion with our speakers and amongst ourselves. So thank you all so much. Thank you.